In this lesson, we will learn how Active Directory topologies are generated between sites. We will start the lesson by adding a new site into an existing AD forest, and in the new site, we will install a new domain controller. Then we will learn what basic information KCCs use to create intersite connection objects. After that, we will learn how the intersite topologies generator is elected and how Bridgehead servers are selected by the intersite topologies generator. Finally, we sum up our lesson with the keynotes. As you can see, this is our existing AD forest. The forest has two domains. The root domain is it-skills.local, which has four domain controllers from CPVDC01 to CPVDC04. The child domain is hq.it-skills.local, and it has one domain controller, CPVDC11. The entire AD forest exists in one site named Chicago. Now we create a new site and name it Aurora. Between Aurora and Chicago, we create a new RPC over IP site link and we name it Aurora-Chicago. The Aurora-Chicago site link is a site with cost and replication schedule. Now we promote OPVDC01 to a domain controller in the child domain hq.it-skills.local in Aurora site. The KCC on OPVDC01 checks in the site configuration and finds OPVDC01 is the only DC in the site. Therefore, the KCC elects OPVDC01 as the intersite topology generator and the bridgehead server of the Aurora site. Being the intersite topology generator of Chicago site, the KCC on CPVDC01 finds OPVDC01 in the tri-domain hq.it-skills.local, acting as the intersite topology generator and bridgehead server of Aurora site. It then promotes CPVDC11 as the bridgehead server of Chicago site. This is to allow CPVDC11 to replicate all the AD partitions with OPVDC01. The KCCs on CPVDC01 also demotes CPVDC01 from the bridgehead server role. Being the bridgehead servers, the KCCs on CPVDC11 and OPVDC01 check in their configuration partitions for the following information to create intersite connections. The first information is the site link. This is to allow the KCCs to determine possible paths between sites. In this case, they will find Aurora-Chicago site link. The next information is the site link cost. This is to allow the KCCs to calculate the least expensive replication routes between sites, and in this case, it finds the cost of 100. The next information it checks is the replication schedules. This is to allow the KCCs to ensure the connection objects are only used during their availability schedules. So in this case, it's only make the connection objects available every 1 hour. The KCCs on Bridgehead servers also check which transport protocol is being configured for assigning RPC over IP or SMTP. In this case, it finds RPC over IP. As you may know, RPC over IP protocol can be used to replicate any Active Directory partition. SMTP protocol cannot be used to replicate domain partition. It can only be used to replicate global catalog, configuration, and schema partition. The KCCs then check if there is any existing connection objects manually created between the bridgehead servers. And finally, the KCCs on bridgehead servers continue to monitor the bandwidth and network topologies for any changes and adjust the connection topologies between sites accordingly. Upon checking the information, the KCCs on OPVDC01 creates an inbound connection object from SHIP-PVDC11 to OPVDC01 to replicate all the ID partitions. Similarly, the KCCs on SHIP-PVDC11 also detects OPVDC01 and creates an inbound connection object from OPVDC01 to SHIP-PVDC11 to update any changes from OPVDC01. Here is how the intersite topologies generator or ISTG's role in a site is elected. When a new site is created, the first domain controller placed in that site will assume the ISTG's role by default. If there is more than one domain controller in a site, the KCCs will elect the domain controller with the highest outbound replication capacity to serve as the ISTGs. The KCC will consider factors such as the processing power, the version of the operating system, and the available bandwidth. If the current domain controller serving as the ISTGs becomes unavailable due to a failure or maintenance, the KCC will automatically elect a new ISTGs from the remaining domain controllers in the site. The KCC periodically re-evaluates the topologies and assigns the ISTG's role if it determines another domain controller is now better suited to perform the role. Administrators can also assign ISTG's role to a domain controller in a site. The easiest way to find out which domain controller is currently holding the intersite topology generator role in an Active Directory environment is to log on to a domain controller and open command prompt as administrator. Then type in the command repadmin /istgs, then hit enter. As you can see, there are three sites in this AD forest. The first site is Chicago and the ISTG is SHIP-PVDC01. Elgin site has the ISTGs as LHPVDC02 and Aurora site has ISTGs as OPVDC01. Here is how the ISTG selects bridgehead servers in a site. The KCCs on the ISTGs automatically selects one or more domain controllers within a site to act as bridgehead servers. The KCCs will choose the Bridgehead servers based on the server's capacity, connectivity, and the ID partitions that the Bridgehead servers can replicate with the Bridgehead servers in other sites. In this case, SHIPVDC01 selects SHIPVDC11 as the bridgehead server of Chicago site because it has all the partition to replicate with OPVDC01. If a bridgehead server becomes unavailable due to failure or maintenance, the KCC on the ISTGs will automatically select a new bridgehead server to take over its replication duties. Administrators can designate certain domain controllers as preferred bridgehead servers. The KCCs on ISTGs in each site runs periodically every 15 minutes by default to monitor the health of the replication topologies and may reselect new bridgehead servers to respond to changes in the network environment. The easiest way to find out which domain controllers are currently holding the bridgehead server role in an Active Directory environment is to log on to a domain controller and open command prompt as administrator. Then we type in the command repadmin/bridgehead, then hit enter. As you can see, it lists all the sites and the bridgehead servers in each site that are responsible for replicating with other sites. Here is how you read the bridgehead server information in Chicago site. So in Chicago site, we have cpvdc01.itlifeskills.local as the intersite topology generator. And we have shipPVDC11 as the local bridgehead server with Elgin sign, and it replicates domain DNS zones configuration partition, forest DNS zone, and the domain partition for the domain hq.itlifeskills.local, and the operation completed successfully. At the same Chicago site, we have shipPVDC11 access the local bridgehead server with Aurora sign, and it replicates forest DNS zones domain partition for the domain hq.itlifeskills.local and domain DNS zones and configuration partition with Aurora sign, and the operation completed successfully. Similarly, you can read the bridgehead server information for other sites. This is the end of this lesson. Let's read the keynotes.